Well, welcome everyone. I'm Alan Taub, professor of material science and engineering and mechanical engineering at the university and director of our electric vehicle center. And want to thank everybody for registering. We actually had a record registration for this third surge session webinar. Uh, at the Electric Vehicle Center, we started building our roadmap of projects on the on-vehicle components. And as we move into 2025, we're going to expand our portfolio to looking at what do we really need to do for the charging infrastructure. And so to get everybody calibrated for that, we're having now our third webinar. And it's my pleasure to introduce Richard Mueller. Richard is the engineering manager at DTE for new technology standards, grid interconnections. He has over 20 years of experience in the field with a long list of his responsibilities within DTE. I've had the pleasure of interacting with Richard at the Governor's Council for Future Mobility and Electrification. And when he gave a presentation on the challenges for the infrastructure, I said, Richard, would you please now do it for our audience? So, looking forward to the talk. I'm sure everybody is going to enjoy it. The way we run this is please we'll take questions at the end, but feel free to put them in chat. After Richard is finished, either you can raise your hand in the Teams meeting or we will read your questions from chat. So with that, I'll turn it over to Richard.
All right. Well, thank you so much, Alan. Been good to work with you and excited to do the presentation today. So I'm going to get started. Just let me know if the presentation shows up properly, and then I will run through it from there.
Yes, it's working, Richard.
All right. Thank you. So as Alan said, manager for new technology standards and grid interconnections in distribution operations at DTE. I'm going to talk about grid capacity and readiness for EVs today. So high level at DTE, just to give you a scope and scale of what our little corner of the country has. 2.3 million electric customers in the Southeast Michigan and Greater Detroit area. There's 5 million registered vehicles within that footprint. We have about 11 gigawatts of peak load today. A lot of that is heavy industry, advanced manufacturing, and logistics. But our service territory ranges from very urban, obviously in the city of Detroit, to very rural, up in the thumb and very agricultural areas. We have a lot of vehicle OEM, technology suppliers, battery research, autonomous R&D going on in the area. So we've had the opportunity to be able to see a lot of what's happening in electrification. A lot of the new and upcoming stuff has been coming to us to be able to look at. So we do have energy services in 35 plus states, and we do have a gas service territory that is greater Michigan area, somewhat overlaps with our electrical territory. So for today, I'm going to talk about grid readiness. I'm going to talk about managed charging and really sort of focus in on where we're at today, what's coming, and where do we want to be, and use those as thought starters for this this collaborative that's here. So a big thing to think about is transportation electrification is one of the largest potential increases to load that is going to be in the electrical industry. We see it as very similar to what happened when there was AC electrification for air conditioning. This is also coming in at a time when we've got increased loads for other electrification, data centers, and all those things. But the big thing that's really interesting about this is it brings together the transportation sector and the electrical sector in a way that wasn't there before. The fuel requirement for vehicles was a liquid fuel and liquid fuel transportation. And now we're looking at electric being the fuel for the vehicles. So there's a lot of need for coordination, and there's a lot of sort of questions about adoption rates and range anxiety and all those things that drive acceptance of the EVs. But it definitely provides that sort of unprecedented opportunity for decarbonization, electrification, and bringing these industries closer together. So when we look at electrification, that has to be taken into account with many other demands that are coming from our customers. There's EV electrification, which, obviously is going to produce new loads for the grid and new locations those loads need to be connected. We also have, increasing distributed energy resources, solar, battery, microgrids, all of those things coming on the grid that are changing how it operates. And we have increasing customer expectations. We have expectations around reliability and availability and, very importantly, affordability of the system as we add all of these other things to the grid and try to integrate them together. So, we have to keep all of those in mind when we're looking at when we, see how the grid is going to be prepared, but also how we're going to build it out for the future. So we do have a transportation electrification plan. A lot of utilities have these based on, which state they're in. Either it's required or they put together a plan. I think, the important thing is to look at how does the plan incentivize electrification across multiple different segments. So single family, multifamily being, a big area where it's difficult for charging to occur in multi-unit residential and apartments, and also making sure there's enough public chargers and corridor chargers for those long duration trips and for when people need to charge when they're away from home. In our case, 40% of the PROS rebates are targeted towards economic justice communities for low income, disadvantaged, rural, and also for things like transit and school buses. And we want to make sure that we're increasing the amount of charging that's available and providing those incentives out there for charging to be deployed by those that want to do it. So a lot of this is rebate funding and looking at how to support those that want to install chargers and fast chargers across our service territory. Another thing is being open about where we have capacity and where we don't have capacity, and making sure the programs we do have and the incentives that are out there are available and knowledgeable for those people that are out there that want them. So a big thing about especially when you're looking at fleets for customers that would have lots of fleet vehicles or other infrastructures, having consulting services to make sure that we can inform them of what options are available, what the capacity is at their sites, what's needed to do upgrades if needed, what the benefits are for electrification, and also, providing those incentives and making sure they're hooking up with the right incentives. Some of them can be linked together depending on where they are or what type of load they have, and making sure that any programs from Make Ready, which is basically a term for making the electrical infrastructure ready so they can install the charger on it, making sure they understand those and navigating those programs. So a lot of services there. So, outside of our service territory, other utilities, we always encourage people to look at talking with the utility to understand what those programs and incentives are, and to see if their utility has a hosting capacity map that talks about where there is capacity if they're looking to, build out EV charging in areas where they're unsure or don't necessarily own the site yet, through like a charging network. So a couple notes on the actual grid readiness itself. We've been doing a lot of work. We've been performing studies since about 2009, 2010 with the Department of Energy, looking at the impact of EV charging, understanding how peak and time of use type of rates incentivize customers to charge at times where there's capacity and try not to charge at peak load times. And we've been using that information to build that into our plans for analyzing substation upgrades and circuit upgrades, and knowing how we're going to do our larger aerial plans, and integrating that with our plan. The scenarios that we're looking at for DER and storage and other electrification. A big thing about distribution is it's very, very local. Which side of the street you're on matters. You might be served from a completely different circuit with completely different capacity needs. And so understanding where things are in the grid, where they might electrify, is a lot of the things we're looking at in our analytics and understanding, because when we look at general load growth from customers, they're only looking at small load incrementals, but then they have a construction project, maybe a new subdivision's going in, or a new shopping center's going in. we'll see those things, but electrification sort of comes in behind that in a lot of cases. If it's not new construction, you have upgrades that may be needed on the grid where the infrastructure was built for the existing load and now it needs to be built for this new EV load. So, sort of demonstrating on the right there that the pockets of electrification, when you go from, let's say, 10% EV penetration to 30%, you get a substantially more load in certain areas than others. It's very, it's not very even. It becomes very lumpy based on where it is, and especially things like DC fast chargers, fleet depots become a lot of concentrated infrastructure and a lot of demand on the grid. So we've spent a lot of time looking at how to plan for not just electrification of residential charging, but also this fleet charging, and looking at locations where you may have vehicles that we don't have electrical infrastructure. You can imagine those areas, school buses are a great example. There's a huge opportunity there for vehicle to grid, but a lot of school bus lots are basically gravel lots with a fence around it, maybe some security lighting. There's not a lot of electrical infrastructure. Now you're going to turn that into a charging depot that might need a lot more electrical infrastructure. So looking at those areas on the system where vehicles are or vehicles are fueled, but that may not be an electrical infrastructure today, and it needs to be in the future. And a big piece of that is EV charging is one of the highest demand energy loads a customer can install. If you look at a residential customer and how they would normally be served, they may average between 0.5 kilowatt and 1.5 kilowatts an hour. Air conditioning might bump that up to 3 to 5 kilowatts. But your average EV charger at level 2 is an 8 kilowatt charger. A lot of cars are now coming out with 11 kilowatt, and then you have options for 20 kilowatt and above for some of the larger vehicles and higher performance vehicles. So now you're talking about one vehicle being the equivalent of 4 or 5 homes for a duration in the evening or when they charge. So you can couple that with some of the demand for electrification of heating and hot water, where there might even be more substantial loads from some of those instantaneous loads. And you compare that to electrical infrastructure, where a residential transformer today might be 25 or 50 kW, but it has 5 to 7 customers on it. So pockets of electrification will require some local upgrades, especially if people have more high-powered vehicles in those locations. When you get into fast chargers, you look at 50 kW up to multi-megawatt. And we always like to, sort of point out, it's like, in our area, Myers has, partnered with Tesla. So you have a Myers, which is 750 to a megawatt of load, and then the Tesla superchargers are out in the parking lot. It's another megawatt of load. And there's only 10, 12 chargers there if they're, fully occupied. So, EV charging is a very high demand electrical load, but it's also can be very intermittent depending on when vehicles are there and when they need to charge. So managed charging, the reason I want to bring it up is it's one of the definite topics of things where we improvements and we can get a lot of benefit from. And so, where are we today? There's a lot of infrastructure that is out there today that allows you to shift the peak demand from EVs. This could be through the telematics or through the charging stations there that are, have some software on them, or just the vehicle has a timer and you can set it on the app on your phone and set the vehicle to that. So you can do some peak shifting and demand shifting to say when would somebody actually charge. And at a regional level, you can do that across a lot of chargers, and you can actually affect total peak demand. But that's not typically targeted towards distribution constraints, which, like I said, could be very local. So managed charging works well with fleets, charging depots, workplace charging, where you have sort of known utilization schedules, when vehicles are going to be there. You have some options for deferring the charging time because there's not a need at a certain point for that vehicle to be charged. Residential, that tends to be mostly daytime versus nighttime charging, trying to shift off-peak to nighttime. So you can help use that to reduce the risk of system and service and transformer overloads, and probably reduce grid upgrades by just using some of the time shifting. And an example here is one of our charging programs where you can see where people are assigned into the charging program, and they, overnight, basically the first part of the graph being midnight, you can see that, charging happens overnight, it tails off. Low charging during the day, you get to about 8 p.m. And that's when that schedule shifts from the time of use, and that then triggers sort of a first bank of charging. And then around midnight, you get that second bank of charging for the rest of the vehicles, depending on which rate they're on. So managed charging does allow you to make a big change from that peak, and shift a lot of the energy there. But again, this is sort of a regional view of it. It's not sort of targeted to a constraint that may be during a specific time of the day or a specific area of the system. So if we want to get the most out of EV charging, we really need to look at interoperability with the grid and cybersecurity of that interoperability. So a lot of the managed charging today goes through a cloud service. You have to have communication to the vehicle, and you go up to the cloud. The cloud talks to the utility gives a schedule, and then back down to the vehicle to tell it to charge at a certain time. Or if you're doing peak like emergency peak type of thing, you'd actually send a signal to curtail the charging through that service. That a lot of times can really easily fulfill the day ahead and sort of regional load use cases, but you pretty much have to have custom integrations with those specific vendor systems. So, there are interoperable standards out there that can be adopted, and as the technology evolves more, there's going to be more capability and more functionality unlocked. So, we advocate for that interoperable standards. And then, when we consider grid constraints being local and problems being local or, temporary, it's going to be very important for the grid to provide the charger and location some real-time information and settings to inform it how to actually operate. So you can imagine that there's a failure of a piece of equipment on the distribution system, and in that area alone, we need to maybe reduce load so that we can make repairs without shutting people down. We need to be able to have that ability to say, in this very localized area, these specific areas need to curtail charging until we can make that change, and then allow us to do the switching to bring them back online. And if there's vehicle to home where they can offset load, or a vehicle to grid where they can actually send power back into the grid, we may want to enable that functionality and say, hey, can you provide that power right now, because that localized offset would be really useful. There may be other times when we say, we really don't want you to send that extra power in the grid because it will actually make the constraint worse. So be able to utilize those sort of currently available and sort of near future vehicle to home, vehicle to grid, it's going to be really important. And we know that AC bidirectional charging is coming soon. It's, in the standards being developed, the vehicles support it technically. There's a lot of capability out there. There's a lot of work needed to make that really coordinate well and make sense together. So when we go and look at that managed charging, we expect that you can get about a 40% peak demand reduction from EV charging. And we've seen that with some of our vendors and working with different people in benchmarking, is that they're hitting that target, or 35 to 40% of that peak demand. And that applies to those day ahead or emergency events, shifting peaks, or when renewables have oversupply, can you utilize that? This allows that higher utilization of the grid, but again, it's still pretty regional. But the big benefits are lowering the charging costs, to take advantage of those off-peak electricity rates. If you don't need to charge right now and you're not leaving right now, and your vehicle has some time to sit there, might as well take advantage of the lower rates. And then obviously any incentives or discounts for being in those managed charging programs for those emergency or emergent events. So if you look at the different ways managed charging is done today, you have targeted programs where basically you get an incentive for meeting a target over a period of time. Like, over this month, your total charging was X during peak and Y off peak. You get a incentive for that, whether it's a gift card or rebate or off your bill. Time of use pricing, basically saying at this time the cost of electricity is a certain value, and that incentivizes shifting of load. And then active demand response, where you send a signal and the vehicle responds to that and either curtails or reduces its charging. Smart charging would be actually adjusting it based on schedules and signals more dynamically. So instead of it just being sort of an all or nothing, being more proactive about when you should charge, pre-charging when there's a lot of capacity available, and curtailing charging when it's not, and responding to those dynamic signals. And then controlled charging would be where it's actually sort of centrally optimized by an aggregator, an operator, utility. We're also seeing the newer options of vehicle to home, where the vehicle can provide that power to the home and offset it from the grid, or actually providing V2G and grid services back into the grid above and beyond what the home load is. So where are our challenges right now, and where are there opportunities to sort of look at different solutions? So policy and regulation is a big piece of this. You got to have the right regulations and policy that allow these programs to be created and allow those different interactions to occur. The program has to make sense. It has to make sense for the customer, and it has to make sense for the utility, and it has to make sense for any of the third parties or aggregators in it. So that bottom line obviously is something that needs to be considered. Another huge part of it is, are the customers actually even aware of that program, and are they willing to participate when that program's available? That's actually been one of our biggest challenges is, you can advertise it, but do people understand what benefits it has for them? And then if you advertise it, do they even open the advertisement? If it's through email or calling or, different social media programs, the actual attachment rate is very low. Most people just don't look at those things. So, it's that education and awareness is huge. A lot of concern from customers about data privacy regarding vehicle and charging behavior. So we have to be sensitive to those and make sure that that data is protected and only used for the operation of the program, and making sure that security is there. And then also the interoperability between the chargers, the charge management systems, and the grid. The big goal is to make sure any vehicle can plug in anywhere and charge. But if you want to enable these programs, you got to add to that any vehicle can charge in anywhere and participate in the programs that are available at that location when needed. So that's an extra step. And making sure that the infrastructure works between the vehicle and the charger, so that you don't have a vehicle that can't charge due to incompatible plugs or software or charging networks. There's also the need for making sure that the charging services actually know the grid condition and can adapt to that and understand how to do that. And then there's a lot of sort of fragmented marketplace. You have lots of sort of independent charging networks, proprietary interfaces, proprietary software, different mechanisms for payment, chargers that might be gated between programs. So there's a lot of things there that provide challenges to that wide scale adoption of managed charging and unlocking these benefits. Want to talk a little bit about vehicle to H and vehicle to G. So vehicle to H is vehicle to home. It's available on the market. There's multiple cars and vehicles that have this. A lot of it's emergency power backup, which is great. It could either be a mobile, generator for being off grid or for remote locations, or backup for the home. Provides peak load shifting, power in the home, during those DR events and pricing periods. Providing that sort of smart charging capability as a battery for the home. And if you've got other renewables, integrating those into that system to store that energy, and supplying that back into the home when renewable generation is low, if you have time shifting that. For some of the issues here, how much do you reserve for the home versus the vehicle? Are you leaving to go on a long trip? Are you just doing a short trip? What was your current charge rate? Are you charging at a time when you don't have energy? Once you've gone off grid, how do you come back? How long does it stay off grid? How long does it wait until things have stabilized if it's for an outage? Those things need to be considered. A lot of this is very vendor specific and proprietary now. That's changing as the standards are catching up, and there's more vehicles that have it. You need extra equipment at the home. You need additional interfaces. The certifications standards are in flux. And then how do you integrate that with other smart home things, in terms of lighting and appliances and other energy usage on the site? Is that part of the system or part of a separate system? It's very complex for a customer to sort of figure that out. So ways to simplify that would be great to make this more widespread. Vehicle to grid, V to H, also is here. It's beginning to be deployed. Can pretty much do anything that vehicle to home can do. So a lot of these things are very similar, but a big thing is that you can actually export to the grid, interact with the grid, provide grid services, provide some more optimization, and not only act off grid but on grid when needed. So a big opportunity for that, not only from the demand response side, but also ability to sell back surplus energy. And then in the cases where there's fleets or school buses with very known load profiles and downtime, huge opportunity to use that as energy storage for the grid. Vehicle to grid issues, very similar to vehicle to home. How much do you reserve for the vehicle? How much do you reserve for the home? But now you add in things like interconnections and requirements, timelines, because now you're interacting with the grid. Probably needs even more equipment than vehicle to home. Again, a lot of systems, very vendor specific and proprietary, local and hybrid control interfaces. If you think about, you have a home that you can isolate, and now you want to make that participate in a larger microgrid that's on the grid scale. How does that single site know that it's in the microgrid and that there's constraints in the microgrid or not in the microgrid? So if you're sending everything up to the cloud for your controls, how does that know that the microgrid is operating and you need to coordinate with it? And more importantly, if you lose communication out to the internet because of a weather event or other outage, but you still want to have that resiliency, if you don't have that local or hybrid control interface, you can't coordinate with the grid, so you're sort of left on your own, and now you're not supplying energy and services to that local area to help beef it up. So that's an important gap right now. Certification still in flux on a lot of things like power control systems and interconnections, so you can do it, but there's still aspects of it that are new to market and maybe not gotten through all of the standards yet. So what are the things that are coming that are going to make this better, but also more complex? Well, we know that AC bidirectional charging is it's coming. Basically, if you can imagine one plug, one set of wires, all software controlled. Vehicles right now, some cases are a firmware update away from making this happen. This means you don't have to have an AC and a DC. You can use, the Tesla standard, the NAC standard for connecting. So now you've got two wires. It could be AC or DC, depending on the software. So greatly simplifies that connection for the hardware. But it also means that now every EVSC potentially can be a grid interconnection. And now you need to have the ability to understand what at each site, how that is controlled, what it means, what are limitations. The DER system now has to enforce those limits, because the vehicle can't be the point of enforcing it, because the vehicle could have driven from Tennessee to Michigan and has completely different constraints where it connects. So the DER system at the specific site needs to know what can the vehicle be allowed to do and pass that on to the vehicle, so the vehicle then behaves appropriately for that location. In terms of specifically, how do you do that? How do you communicate it? You may have to provide not only the performance curves and the criteria for returning to service, but also power control system things. So how much can be exported, how much can be imported, and also the program limitations. Is this site participating in a program? That has to be communicated as well. So there's a lot of complexity to it that needs to be sorted out in practical terms. I think a lot of the technology exists. It just, it's making it end-to-end work seamlessly and make it easy to implement is going to be the big challenge. We also have a number of things that we're seeing in the utility industry that are going to make this even more interesting. FERC 2222 is a regulation that requires that market access for DER and DER aggregations. And so now vehicles would be able to participate in that as a storage resource. So we need to understand how that works from not only a distribution program, but also now a market program that would be more regional and participation in there. And then we also know that, the FERC 901 requirements are going to be requiring us as utility to provide much more accurate models of the system to look at how the impact on transmission will be felt and be able to perform those studies. Right now, we don't know what that lower limit for the individual model will be, but we know that most of the fleet depots and larger fast chargers will probably meet that requirement. And then, that may become even more of a requirement going farther down. And as utility, that becomes a very interesting problem because now the inverter on the vehicle is moving around. And the system model basically changes every time a vehicle plugs in and unplugs. And it may be a different inverter, a different vehicle with a different capability. How do we handle that modeling? So there's a lot that has to be done dynamically. That's currently a very static modeling process in the interconnection space. So grid services, want to talk a little bit about the different options that are there and some of the interesting facts that are there. A lot of people talk about virtual power plants. So, looking at very good alignment if vehicles are there. If they're not, then, the actual capacity of that virtual power plant is very much in question. So fleet service type of thing sounds really good in this space. Otherwise, it's going to be a lot of sort of participatory, vehicles charging, not charging. If you imagine if a vehicle's fully charged, it won't provide load. Of course, if it's completely on charge and needs to do that, so the ability for the virtual power plant to shift is going to be very much dependent on the state of charge of the vehicles at that time, but could be very good for short-term demand events. You need the availability from those systems of that state of charge to really understand how that can be done for capacity and reserve. You need to make sure the vehicles are connected and in the right mode to do some of the faster response services. And then, for things like renewable firming, where you'd actually sort of back up renewables and smooth them out, you need to make sure the vehicles are needed or available and have capacity or don't have capacity during those times. So there's a lot of variability in that, but EVs can potentially provide a very interesting role in virtual power plants. For voltage support, similar challenges there, but can be done today in some ways by deferring peak or charging when there's excess renewables. The passive support means you have to be plugged in online and ready to do that service. And then again, some of the needs are very local. So you need to understand where the needs are at a specific time to activate it and some communication to do this because it's going to be a very real-time interchange. It's not something you do sort of regionally over a long period of time. You're talking about, seconds and, minutes at worst for some of these responses. So the resources need to be there. They need to be in the right configuration and connected. And then when you get into resiliency and microgrids, a big thing is you need to make sure that they can operate autonomously and resiliently when the outside world sort of disappears. That's the big piece of the microgrid being resilient. So if you don't have communications out to the internet or out to a central server, you need to coordinate locally, you need to be able to optimize locally, need very fast response time to maintain stability and the balance of load and generation. How does a resource know it's on a microgrid? How are those resources, sort of statused and enumerated into the system? How do you communicate those goals out to those resources? So, you've got questions on grid forming versus grid following, interoperability and conformance of those communications, the hybrid and local communication interface, dependencies on proprietary or cloud or web services, and then making sure it's secure, support for patching, security patching, endpoint product. Things go out of security compliance very rapidly in the IT OT world. So how do you keep things secure and communicating when you have these complex systems? So lots of questions in the microgrid space, but again, technically feasible. Just a lot of pieces need to get in place to make it work well. And then non-wire alternatives. So grid deferral of investment. Managed charging has a great opportunity here to do some of that, to defer some upgrades that EV charging would cause, but it's got to be very targeted. It's got to be very local. Needs to be looking at how the grid is structured in that area. Needs to be in the right location in that portion of the grid, because if the constraint is on one side of a circuit versus another, it doesn't help you to relieve the constraint on one side if you're overloading the other side. most grid upgrades are tied to demand capacity, not energy. So reducing demand is way more important than energy over time, unless you're looking at trying to balance out storage. The resources have got to be there when you need it, and they got to be there consistently when you're considering that versus something like a transformer upgrade or a wire upgrade. So, the constraint maybe when the vehicle's not there. So you got to make sure that those things are considered. Um, you still need to charge the vehicles, and you can imagine having a consistent constraint over a 48-hour period if you don't have time to charge the vehicles in between, because that constraint is there for that duration. Then the vehicle needs to leave to charge, or it actually creates a problem when it charges. Need to look at contractual language and firming, and then understanding, how much overcommitment is needed to meet the goals. So again, those gaps that were in that microgrid space of interoperability and standards, interfaces, dependencies, all of those apply. But also, how can we utilize these resources? I brought up here also at the very bottom is secondary use. A lot of opportunity there for used EV batteries to become storage that can be used for non-wire alternatives, in conjunction with the live vehicles that would be out there with vehicle to H and vehicle to grid. So lots of things to consider in this space, but a lot of it ends up being very specific to the location on the grid and the nature of the constraint. So I'm going to end with a couple next steps here. So long-term goal, we really want to have dynamic grid services provided by those mobile resources. So we'll need to know where the capacity is at a given time, where will vehicles needing to charge be, and when, and how much capacity will they have, how flexible will the customer be in providing that charging, how deep will they go into the battery, when vehicles need to charge, where will they be and when, how much flexibility will the customer have in actually charging and discharging. When a vehicle plugs in, we need to have a capability to say, these are the services the vehicle can provide. This is the status, the state of charge. This is when it's going to be there, when it's going to leave. Need to inform the vehicle of those site limitations. So we need to be able to tell it, here's what you can and can't do at this location because of the grid configuration. And then we need to make sure that we have a way of saying, hey, the service is now required. This is now a service that we can, dispatch, or here's how much of that service we need. And then having some way of communicating the forecast the charging needs, the forecasting of the availability of the vehicle, and what the customer preferences are and the availability of that vehicle. So lots of pieces here, open for exploration, and lots of potentially really good ideas and capabilities. So just a summary of things that we're going to need to make this all work together. Need to streamline the interconnection of vehicle to grid. That includes having robust scenario analysis tools of grid constraints and programs and capabilities of vehicles. We need to have local and hybrid communication information interfaces to enable those microgrid and local services, and inform the DER of the objectives and limitations and site-specific things the EV needs to know. Need to coordinate beyond the individual house or premise and interact with the grid. That's going to need you to have interoperability and conformance to the standards so that every car works with every plug and all the charging infrastructure works with all the different pieces of the grid without those custom integrations that are fragile. We need to have cyber strategies to have security over the long term. And then we need to make really good accommodations for secondary use. What are the market pathways? How is it used? And how is it competitive with new storage that could be bought, versus using the used storage? So lots of things that are opportunities out there that I wanted to sort of, highlight. But I think I've gotten through everything I wanted to talk about, and I think I'm ready to move on to questions.
Well, Richard, thanks so much for a comprehensive look at the challenges, but also my takeaway is cautiously optimistic that we have the approaches to meet them. What I'd like to do now is turn it over to Jamie, our communications director, to handle the questions.
Yeah, thanks, Alan. Thanks, Richard. Nice job. You can stop sharing your screen so we can see you as you answer the questions, if you don't mind. We have a few questions coming in the chat. Feel free to add some more. We got about 12 minutes. First question from Stephen: how are you dealing with the update from Ontario, Canada utility not selling electricity to Michigan?
I'm not too sure about that one. I know that there's regional power interchange agreements and markets that allow us to buy and sell. So as of right now, I'm not aware of that having any direct impact on anything.
Okay. From Angela, it was my understanding that fast charging is not needed when charging from home if it's done overnight for 8 hours. How much energy consumption are EVs using when we don't use fast charging?
So I think that's a really good statement, and I think it's pretty accurate. Most home vehicles, I mean, at least in our service territory, talking with the OEMs and looking at actual charging behavior, most vehicles drive 40 to 50 miles a day. So the amount of charging that's needed on any given day or evening is pretty minimal, maybe even only like 1 or 2 hours. So that provides a lot of opportunity for that managed charging to sort of levelize that out. If you know that the vehicle is going to be parked from 11 p.m. till 6 a.m. and the vehicle only needs 2 hours of charging, you could start that charge at 4 a.m. or 3 a.m. or 2 a.m. So, when you get into the larger vehicles that are more heavily used, if you take like one of the F-150s or a Silverado, you drive it down to 10% of charge, you're going to need 8 to 10 hours to charge that back up on level 2. So I think a lot of it depends on the charging utilization, how much you drive. Um, we would agree that fast charging is really more for, hey, I need to get from one long distance location to another, or I'm a high utilization driver where I'm already driving 300, 400 miles in that day, and I need to charge multiple times, and I don't have that downtime. So I would definitely agree with the fast charging. As far as energy consumption, from an efficiency standpoint, I don't necessarily have any specific numbers, but depending on how a DC fast charger is configured, especially if there's on-site generation or storage, you might get a little bit more efficiency on a DC to DC because you're not converting from AC electricity to DC and then back. But in general, I'd say they're roughly comparable at high level, unless you have some opportunity to reduce some of the conversion losses.
Good. Jim asks, what are you doing to reduce the time and cost of interconnection studies for new fleet installations?
So a big thing that we're doing right now is when I talked about those fleet services, reaching out to the different customers that have the potential for electrification. So those people that have a lot of transit, delivery, shipping, or fleets, reaching out to them and understanding what their timelines and plans are, so that they're not saying, "Hey, I just bought a charger, I need to connect it." It's all right, I'm going to buy, 20% of my fleet will be EV in 2026. What do I need to make that happen? And then I'm going to do in 2028, I'm going to do another 20%. What do I need to do that so that the interconnection is not the last thought that they have, that they understand some of those things that need to be done up front to allow some of those larger connections to come in for those fleet depots. Because again, they could be rather large infrastructure needed. So just being very proactive with fleet owners and understanding what their plans are and where they plan to electrify. For general use, if it's smaller individuals or smaller companies, just working on having some of the grid studies and tools that just streamline the process in terms of understanding where capacity constraints are and what upgrades might be needed. The more we can do that, it helps all DER interconnections. So,
And Keith's question is, how do consumers get electricity pricing information for time of use charging?
as of right now, for our programs, our time of use is just part of the customer's rate. So if they're on a specific program, they would be, sort of assigned time schedule, whether it's 7 p.m. to, 11 a.m. Is off peak, or if it's 8 to 9 or whatever it is, that would be part of their rate. As far as more dynamic pricing, not too sure about how that would be communicated directly, but it could be through some of the programs. Like I know for like home heating and thermostats, some of that goes through the thermostat vendor, so they get to see that on the thermostat or in an app. So there's a couple different options there.
Yeah, that's great. I have some reminders on my chargers to charge between 7 and 11, so keep the rate down. Peter asks, he says, recognizing the challenges of decentralized energy generation for a grid owner, do you see ways new technologies could make it less challenging for microgrids, whether at the home or business level, including for EV charging sites to be approved to connect to DTE's grid in the future?
I think the big thing comes into that interoperability and conformance to the standards. If it's conformant, tested, and has that interoperability, that integration becomes very easy. We still have to look at impacts on the grid in terms of what site-specific changes are being made, but we don't have to review the type of connection that the microgrid has or the type of controls it has, because that standards conformity really helps take care of a lot of that. So that to me would be the sort of most straightforward thing. I think again, when you get into distribution studies, the big thing is, again, it's very local. So what applies in one spot of the system does not apply in other spots. It's all the same math, but the parameters all change based on what's at different locations. So, um, again, having better study tools might speed up the actual study itself. But process-wise, we still need to evaluate those things.
And Stephen wonders what your thoughts are on a DC to DC charger that his company is developing.
Makes sense to me. I've heard some discussion about, how do you charge a vehicle that's dead on the side of the road, needs to be charged, and some of the standards are allowing for the capability of basically plugging one vehicle into the other to transfer power. So that type of thing is very useful, and I think DC to DC, big advantage of that is you don't have conversion losses in between. So if you have other DER on site, that allows you to sort of not take any of those conversion losses into effect. So should be better for efficiency.
And Ben says, you mentioned how localized grid needs can be and how the local status of the grid could influence V to G operation. Where should this local grid information come from? The utility? Is this information available today?
So I think in terms of availability, we're still working out how best to communicate some of this. A lot of this sort of depends on communication. So, it's what is the site, where is it located on the grid, and what does it need to talk to? That interoperability and communications protocols are going to be really critical for that. And it's going to be, making sure we have the cybersecurity to support that as well inside those protocols and those interactions. So a lot of this would be effectively automated once it's set up. Once those communications are done to, let's say, a local microgrid controller, then that would be sort of participating in that local network and get that information. So it wouldn't be like a human, in the loop. It would be, an automated configuration in the future.
Olivia asks, what standards does DTE use to evaluate and select EV charger vendors?
Right now, DTE does not specifically deploy EV chargers as part of any of our programs. We provide Make Ready. And then our rebate program has some criteria about making sure it meets, there's some UL and ANSI standards. There's, some, things about communications. And then especially when you're talking about incentives through NEVI or some of the other state incentives, there's some additional requirements on, where was it sourced from, and what capabilities do they have in terms of size and demand and number of ports and communications. So we don't directly deploy chargers except in the case for our own fleets internally. But those are, I believe, on our website in terms of our program qualification requirements.
And Hashwan wonders if you have any idea of what the percentage of school buses are electric today.
I don't have a percentage. I know it's a handful right now. The initial rollout in our service territory was like a dozen vehicles, and I think the most recent program that's going out now probably brings that to maybe a few hundred. So, I think there's about 10,000 school buses in the state, and if we have, I don't know, half of them, we're probably still in the 1% range or less.
Okay.
I guess I'm subject to verification by others.
Sure. That's a good. Kyle is asking, are commercial EV charger rebates planned to be continued into 2025, say for hotels and factories and so on?
My understanding is on a program by program basis, the answer is yes. Some of that's supported by state funding, and other, things. So my understanding is that yes, there are continuations of the programs, but would have to check the website with the marketing team to understand what is continuing and what isn't specifically.
And Stephen has another question that he'd like your thoughts on related to developing hydrogen to power DC fast chargers in other states.
I think it's a great use case, especially if you have some excess solar to use to do the hydrogen production, so you can get that green hydrogen, or you have hydrogen from an industrial process that you can readily source. It makes sense, especially in a lot of cases where DC chargers might be difficult to install without some supplemental local generation or storage, to have that, because you can bring in that, fuel separately and have it available for that.
Shannon asks, what specific plan of action or programs do we have to improve the grid infrastructure of supporting our homes and small businesses here in Southeast Michigan? Are we able to reduce the peak grid charges from 2 to 7 p.m.?
All right, for the first one, we have a number of investments we're making in automation and grid hardening. I know that some of those plans are available online. I don't have specifics right in front of me on that, but looking at making sure that we have more resiliency for outages, and supporting load and doing a lot of our conversion work. So there's a lot of ongoing projects and programs there. For the second question, able to reduce the peak grid charges from 2 to 7. I think, that has, you have energy supply rates that are the amount of energy that's coming from the market and the power plants and everything like that. So certainly things like renewables could potentially reduce some of that, energy cost during peak time. And, from a distribution perspective, again, going back to that affordability question of, if we need to make investments in the grid, how can we do that very intelligently and do it in the right spots, to support as much infrastructure as we can for the dollars we do spend? So that's more of an efficiency argument.
Great. I think that's all we have time for. I'm going to throw it back to Alan to wrap us up.
Well, first, Richard, I just want to, on behalf of, I think, everybody online, thank you once again for a tremendous presentation and deep answers to what turned out to be some tough questions. So virtual applause. If it was in the room, it would be a standing ovation. So just to close things out, this is the third and final Surge webinar for the Electric Vehicle Center for 2024. And we focus this month on infrastructure. On January 13th, Greg Keolian will present the results of a study he just published that looks at the CO2 footprint of electric vehicles by vehicle class, by every county in the United States. Should be a really good session. And I would like to remind everybody who hasn't heard us before that on April 1st and 2nd, we're going to be having our first EV Center Symposium. It is going to be free to attend in Ann Arbor on a U of M campus, and you can register today to be informed on it. And we've lined up a really good set of speakers, both from the university and from external. This is for many people their last week before the holiday. I want to wish everyone safe travels if you're traveling, and have a fantastic holiday, a happy new year, and looking forward to seeing everybody in 2025. I'll also remind you that this session has been recorded, and you will get the link to it that you can pass on to others, as well as If you're not yet formally affiliated with the Electric Vehicle Center, if you go to our website, it's free to become an affiliate, and you'll be fully informed on all future events. So, Happy New Year. Have a great holiday. And once again, Richard, thank you so much.
Yep. Thank you, Alan.